This is the energy level diagram. It is a diagram that represents the relative energies of electrons in the atom. Before we solve the problem, draw the energy level diagram of CD. We should first clarify 3 rules and some details when drawing. First is following the off-Bohr principle. Off-Bohr principle theory that an atom is built up by the additions of electrons. Fill up the lower energy orbitals with electrons before the higher energy orbitals. The energy increases from bottom to top. The energy at this side is the lowest energy. When we fill up the energy orbitals with electron, we should fill it in from bottom to top, and you must fill up the previous energy level with electrons before moving to the next one. This chart can show the energy level more intuitively. The second rule is Pauli exclusion principle. This is an orbital. An orbital can hold 2 electrons. We can use an arrow to represent an electron. But in one atom, no 2 electrons can have the same set of 4 quantum numbers. In the same orbital, the electrons have the same NL and more. So in the same orbital, the 2 electrons with opposite spins. An orbital contains 1 upward arrow and 1 downward arrow, represent the 2 electrons. The last rule is Hand-S rule. It means that the arrangement of electrons outside the nucleus must first occupy as many orbits as possible in the same electron sublayer, and the spin direction must be the same. Inward in the same energy level, all the orbitals should be filled with arrows in the same direction. It can be either spin up or spin down. But this one is incorrect because the spin of the third need to depend on the spin of the first electron. And after you fill all the orbitals in the same energy level with same spin direction, you can fill the other electron in this orbital with the opposite direction arrow. Then we can solve the question. We can find the atomic number of cadmium is 48, which means it has 48 electrons. Then we can draw the energy level diagram. Exactly 48 electrons are filled in. Now we finish drawing the energy level diagram. Next we should write the electron configuration of cadmium. Electron configuration means the location and number of electrons in the electron energy levels of an atom. These 2 are all electron configuration. We can use an example to explain the electron configuration. For an example, the oxygen have 8 electrons. This is energy level diagram. This is electron configuration. The 2p4. The first integer 2 gives us the principal energy level, that n equals 2. The letter p represents the type of orbital. The superscript 4 gives us the electron occupancy. The periodic table is a helpful tool in writing electron configuration. But I think that now we can write the electron configuration directly through the energy level diagram we just draw. The highest energy level electron is in the 4d orbital. In 1s orbital, there are 2 electrons. In 2s orbital, there are 2 electrons. There are 6 electrons on the 2p orbital, 2 electrons on 3s orbital, 6 electrons on the 3p orbital, 2 electrons on the 4s orbital, 10 electrons on the 3d orbital, 6 electrons on the 4p orbital, 2 electrons on the 5s orbital. The last energy level, 10 electrons on the 4d orbital. This is the electron configuration of the cadmium, the final answer.